I'm just going to run through tests 1 to 4 that were in the spec. Test 1 is compilation, so I guess that'll be obvious from when I run the other tests that it does compile. You can see I'm on the CSE machines, my good friend Wheel over here. So I've just got a little script just so I don't have to type in every single command that's just going to run through and do test 1 to 4 for both the packet and the circuit network. So just for the 3 different routing protocols, and then you can see there for packet and circuit, and it'll print out what test that it's doing at the time. So I'll run that and see if I can fast forward it while it's printing it all out to the screen and then run through the results. Overall, for circuit versus the packet cases, the packet is always routing more successfully. So here for shortest hop path, we've got 94 versus 91. For delay path, we've got 95 versus 91. And for lowest load path, we've got 97 versus 99. So it's always higher in the packet case, and that makes sense because, if you've got a 20 packet circuit and at the time that the first packet wants to be routed, the path you choose is blocked. In the circuit case, then it's going to block all 20 packets, whereas in the packet case, it'll just block the first packet, and then the remaining 19 will be routed successfully. So that's the first kind of takeaway there. And then in terms of the different routing protocols, obviously, so shortest hop path is going to be minimizing the average number of hops per circuit, so 2.66, 2.63 versus down here you can see for delay we've got 3.3-ish, and then for the lowest load we've got 4.4, 3.5-ish, so yeah, that's what shortest hop path is doing, as you'd expect. Shortest delay path, that's going to be minimizing the average cumulative propagation delay per circuit. These are in milliseconds, so here you've got around 140, whereas with the delay, with the shortest hop path, you've got 165-ish milliseconds, and down here up around 270 to 15 milliseconds. And then the lowest load path, so in both cases has pretty high average number of hops per circuit and average cumulative propagation delay, but it is prioritizing making sure we can actually route on links that have capacity. So, I've got nearly everything routed in both cases, significantly higher than, you've got 90, 91. So again, as you'd kind of expect, in all cases, so I'm using a packet rate of 2 here. So as you'd expect as well, the number of virtual circuit requests and number of packets is the same for every run of these tests. And yeah, that's basically test 1 to 4. The spec also said that I have to show my code. So I'll just bring it up here. So basically, yeah, it's an adjacency matrix, as you can see with these 2 lines. So just nodes and edges, but instead of the edge isn't just a single cost, right? You've got a few things you need to track of on the edge. You've got the propagation delay, the capacity, and then the circuits that are active on the edge. And I go into a little bit more detail about how that works in the report. And down the bottom, you can see I'm reading the jobs into a priority queue. You can see that kind of here and here. And if it is a packet network, I'm splitting each line in the queue, each line of the workload file up into its respective packets. Otherwise, I just push the line on as a request itself. And then I basically just pop those jobs off the priority queue and fulfill them on the network. So yeah, that is my screencast. Thank you.